investment recommendations? What are they based on? Because computers usually do not explain their predictions, right? This explainability, that's a problem. We have some solutions for this. They are too in-depth for this course, as Shapley, Lime, but we do have to take care of this, because you would like to have an explanation why it's making this decision, right? And the last one, who is liable for AI-driven decisions? If there's an innocent person convicted of a crime based on evidence from facial recognition, who's responsible? Because again, an algorithm is not perfect. It makes mistakes. Maybe it's 90% accurate. Is that enough? Or is it not enough? Who makes those decisions? Really some challenges and risks around AI. And, with your peers, have a discussion around these topics. What are your opinions, and how do you think you should tackle these challenges? Next up, we have the principles of responsible AI. Because when we at Microsoft, when we develop AI software, we are guided by these 6 principles. And the first one is fairness. Because yes, all systems should treat people fairly. It shouldn't. Let's make up an example here. Suppose you have a loan approval application for a bank. The model should make predictions of whether or not the loan should be approved without incorporating any bias based on gender, ethnicity, or you name it, any other factor, right? Because it might result in an unfair advantage or disadvantage to a specific group. Luckily, Azure Machine Learning includes capability to interpret models and quantify the extent to which each feature of the data influences the model prediction. Right, so you can look at each feature and see, okay, what does it do? What effect does it have on the outcome? Reliability and safety. Yes, because AI systems should perform reliable and safe. If there is an AI-based software system for an autonomous vehicle, well, you can guess the problem, right? If it's unreliable, it can result in substantial risk to human life. That's why AI-based software development must be subjected to rigorous testing to ensure that it works as expected before it gets released. Let's move on. Privacy and security. Yes, AI systems should be secure, should respect privacy, right? Because sometimes, to train a model, it needs large volumes of data that might contain personal details. They should be kept private. But even after the model is trained and the system is in production, it uses new data to make those predictions or take actions, right? So again, there is this, it's being fed new data, and also that, has to be secured. Inclusiveness, yes. All AI systems should empower everyone and engage people. AI should bring benefits to all people of society, right? Regardless of physical ability, gender, sexual orientation, ethnicity, or any other factor. It should empower everyone. Transparency. All systems, AI systems, should be understandable. You should be made fully aware of the purpose of the system, how it works, what are the limitations that may be expected. And last but not least, accountability, because people should be held accountable for AI systems, right? If there is a problem with this autonomous vehicle, who is responsible? And that's why designers and developers of AI-based solutions should work within a framework of governance and organizational principles that ensure that the solution itself meets ethical and legal standards that are clearly defined. So really just 6 of these principles. And again, it's great, discuss along with your peers, among your peers, who, if an autonomous vehicle has an accident, who is responsible? Is it the person that was driving the car? Or is it the data scientist that developed the model? Or is it the manager of the data scientist who agreed that if the model was 99% accurate, instead of 99.9, it was okay to put it in production? And with that, let's move on to our lab. In this lab, we're going to look at some cards. We have different decks of cards, and we're going to review some example scenarios. And inside those example scenarios, we can identify some responsible AI principles. So I'm going to flip a few cards, but you can do it yourself at home as well at aka.ms/hci-demo. I've already opened the link inside my browser, so let's go there right away. Here we are, and indeed you can see at the bottom different decks of cards. So let's pick the first one here, and it says make clear how well the system can do what it can do. And on the right side of that there are some examples. So in this case you have the Office new campaign experience, there is the word ideas, and there is the word preview. And this gives you a tool that helps you with setting expectations about the percentage suggestions. Another example here would be Apple Music. And Apple Music will say, we think you'll like, when it's suggesting you new music. And this gives some form of uncertainty. And with that, it makes clear how well the system can do what it can do. Let's pick another card. Let's take a red one here. Mitigate social biases. In the example in practice here, you see that there is a calendar, and below the calendar is an icon of a person. And this icon has been made gender neutral, so there is no bias on gender. Let's take another example here. Bing. So when searching for CEO or doctor, it shows you images, but it shows you a diverse set of images in terms of gender and ethnicity. And another example of mitigating social biases is when you're typing something in the Android keyboard and it suggests both genders when you're starting to type with an H, because it can either be him or her. Okay, so let's take another card here. Let's take this one. Make clear why the system did what it did. And we're looking here at the example about Office Online that recommends documents to you, where other people have been working on, and there is a description above it that makes it clear why the recommendation is shown. Another example here would be, let's see, Amazon.com, because there is a why recommended session, and it shows you the products in your history that create the recommendations that you get. And another example here, let's see, Facebook, yes, because it gives you an explanation. Why are you seeing this ad in the newsfeed? So again, making clear why the system did what it did. Let's go to another card. Let's see. Let's pick, let's pick somewhere in the middle here. Encourage granular feedback. Yes. So in this case, in Excel, you have ideas, and then at the end it will ask you, is this helpful? So you can give it feedback. Another example here. Instagram. You can hide specific ads, but then it will ask you, okay, why don't you want to see this ad? What are the reasons behind it? Because it wants to understand why the ad is not relevant. And another example here, you see in Apple's Music, you see a love or dislike button. Both are easily accessible, they're quite prominent, and with that you can easily give some feedback back. Okay. So I would recommend going through the cards yourself at home and maybe discuss these with your peers. Now, if you want to know more, you want to learn more, and especially when you're pursuing some certification, I would advise you to also go to the learning paths at aka.ms/learn artificial intelligence. I've already opened up a browser tab with this, so let me just show you. Here we are. It will redirect you to this page. Get started with artificial intelligence on Azure. It's 27 minutes long, and it's a learning path, only one module, and it will actually also just guide you introductory through all the modules. Just an introduction to AI, understand machine learning, and these topics, right, which we already discussed. Anomaly detection, computer vision, natural language processing, conversational AI, and responsible AI. So again, if you want to know a little bit more and pursuing this certification, would definitely recommend going through these. So, in this module, we covered the following concepts. We looked at what is artificial intelligence, What are some of the common artificial intelligence workloads, right? I talked about the violence detection, spelling checker, and numerous other things. And we've taken a look at artificial intelligence inside Azure. And in the second part of this module, we took a look at the challenges and risks with AI. Remember the bias. And we went through these 6 principles of responsible AI. And with that, let's get started with Module 2. In this module, we'll be looking at machine learning. And we'll start, of course, by just an introduction to machine learning. And we'll look at these 3 types of algorithms, which is regression, classification, and clustering. And after that, we'll take a look at the Azure machine learning, what it is, and we'll take a look at the designer and automated machine learning, which we call AutoML. And well, I'll just demo that and I'll show you around in the portal, and we'll train a model, and we'll show you the designer, and we'll train a model using the automated machine learning. But first, just what is machine learning? And the goal here again is not to teach you linear algebra. It's just to help you gain an intuition on how machine learning works. So, what is machine learning? Machine learning is creating predictive models by finding relationships in data. Now, suppose I'm a botanist. I'm actually not a botanist, but the example is kind of funny. Suppose I'm a botanist and I just collect flowers. And each of these flowers, they have features such as the measurement of petals, or stem, or any other kind of details, color, you name it. Now, I can provide a label, right, for these flowers. So I'm doing this, and you can see here I provided some labels. So on the top left you can see 2 flowers, and I labeled those Bellus perennis, and the top right I named them Rosa multiflora. Now, this sample data I can now process using an algorithm, and I can combine this together, and this algorithm now is going to find the relationships between the features and the labels. And after it has done this, I can now use this algorithm to predict new flowers. So in this case, I get a new flower, and my algorithm will predict then that it's probably a Bellus perennis. Really simple basics of machine learning. No math yet. Okay, so let's start with the first type of algorithms, which is regression. And regression is it's the most common technique, actually, where you want to predict a numeric value, like a price, sales total, or you name it. And for this example, we're going to look at bike rentals. So before we can even train an algorithm, I need some data. So here it is. I have the temperature and the amount of rentals. It's in Fahrenheit, the temperature, so it's not in an oven. And you can see that at 56 degrees, I rented out 150 bicycles. And at the bottom of the chart, you can see that at 80 degrees, I rented out 154 bicycles. So already just looking at the data, it seems that when the temperature go up, my bike rentals might go up as well. So the thing I'm trying to predict here is the Y, is the bike rentals, and we're calling this Y, and the feature is the temperature, and I'm calling this X. Now, I'm not going to put this entire data set into a model because I want to test it as well. So what I'm going to do is split it up. Splitting it up in a training set and a validation set. I'm going to use the training set to train the model, and I'm going to use the validation set to validate the model. Now, in a real-life example, because this is only a few rows, so in a real-life example, it would be more data. I would probably my validation set would be about 20 to 30% of my data. Now, so I have splitted my data, and let's plot it. I'm plotting the temperature on the horizontal axis and the bike rentals on the vertical axis. And here you can already see that there appears to be some kind of relationship. And I could even, plot a line through this, right? Because I'm trying to find some kind of function. So, plotting a line to it, and there is you can see the trend, and there's a couple of things that are interesting, because the point where the line intersects the vertical axis is around 35. And the slope of the line, well, it looks to be around, for every 1 increase in temperature, it looks to go up for about 1.5 bike rentals. Right? Looks about right. So I have 35 as a baseline, and the slope is 1.5. Now, I can create a function out of this, and that would be this function. So this is all the math, folks. Don't be scared. So this is actually my algorithm already, right? Because the function over the temperature, and I can use that. So 35 plus 1.5 times the temperature will be my bike rentals. So let's test it, right? Because now I have my function, and we can test it with the validation data that we held back. And that is not called, those predictions that I'm going to make are not called y, but they're going to called y hat. So they have a little hat on top of it. And you can see here that for a temperature of 54 degrees, my actual bike rentals were 114, and my predicted bike rentals were 116. So there's a little bit of difference. And now you can see how well the model predicts by measuring the difference between the predicted values and the actual values that we know to be true. And this tells us the amount of error in the model. And there are various ways to calculate this error and generate some common metrics that we can use to evaluate a regression model. Now, if I plot again, I plot the predictions here on the graph, and indeed you can see that there is a little bit of error because they're not perfect. But again, perfection doesn't really exist. And this is just this error. Okay, that is a really basic example of regression. And regression is another form of supervised machine learning. And supervised machine learning is when you have data that has a known label value. So in the case of the regression, I knew the amount of bike rentals already. I had the data. And in this case, for classification, we're going to look at diabetes. And I already have some data here with outcome variables. And after classification, we'll take a look at unsupervised machine learning. So for now, we have some data, including some features and a label. And the label here is the Y, whether a person has diabetes or not. And the features are some medical measurements like weight, height, blood pressure, and so on. Now, the label here is 1 or 0. So 0 means not having diabetes, and a 1 means having diabetes. And the algorithm we're going to use will predict a number between 1 and 0. So it is a probability. And we'll take a cutoff value of 0.5 to determine whether a person has or does not have diabetes. But first, let's do the same as with regression. We're going to split the data up into a training set and a validation set. Training set to train our algorithm, and a validation set to validate the algorithm. We're also going to plot these values on a line. Horizontal axis, we've plotted the features, and the vertical axis, we plotted the Y, the outcome variable, or whether a person does or does not have diabetes. And again, like I said, we're taking this cutoff value of 0.5. We're plotting a line through the values, same as that we did with the regression, with the linear regression, but this time we're not putting a straight line to it, it's a logistic function. Okay, so we have that. Now let's look at our validation set. Again, we have a little bit of validation set, and we plot again the values on this line. Now, looking at this plot, you can see a couple of things. The top value here, the top blue circle, is pretty certain that that person has diabetes. Same goes for the person at the bottom. It's pretty certain that that person does not have diabetes. However, the two values in the middle are very close to this threshold. So maybe they're wrong, right? Because there's a lot of uncertainty around this. The top maybe has like a 53% certainty that the person has diabetes, and the other person has a little bit below this 50. Now, using the algorithm, we're going to make predictions, and we're going to the probabilities. And for the first row, we have a probability that a person has diabetes of 0.2, and the probability that a person does not have diabetes is 0.8. And that is this bottom blue circle here. And let me just point it out with a little laser pointer here that it's this one, right? Because the probability is very low that this person has diabetes. And also the prediction, the y-hat, predicted that this person does not have diabetes. So this is truly negative. And that's also what we're calling it true negative. Okay, so let's look at the other one, the second row. In this case, the person has diabetes, and the probability that the person has diabetes is 0.9. And indeed, it gets correctly classified as having diabetes. And this one here is the top value here, and indeed it is, the person has diabetes. We call this a true positive. Now, here it becomes interesting, because if we're looking at the data, you can see that this person does not have diabetes, but the probability of him having diabetes is estimated at 0.6, and he gets wrongly predicted as having diabetes. And this is now a false positive. And the other one is the other way around. It gets falsely accused of not having diabetes while it actually has diabetes, and it is a false negative. So it gets falsely put into the negative bracket. Now, again, if we're putting this in a little table, let's do this right away. True positive, false positives, false negatives, and true negative. So top left, true positive, and bottom right, true negative. Now we can compute some metrics with this. Now 4 rows is it's just not enough. So what we're going to do is we're going to add some data. And with this, with a magical touch, poof, we have more data. And now you can see that there's 126 true positives and 119 true negatives. And only a few false positives and false negatives. So, so it seems to be a very decent model. I'll color those to make it a little bit easier. Now, like I said, I can calculate metrics with this. So what I can do is I could calculate accuracy, which is the proportion of true results among the total number of cases. And I could calculate the precision. What proportion of predicted positives is truly positive? But let's stick with accuracy, right? So just the true results among the total number of results. I can calculate this. So let's do this. 126, you can see it top right here, 126 plus 119 divided by the total. And this brings me to a 0.897. So that's about a 90% accuracy. Now, when accuracy is not always useful, I'll give you the following example. What if I'm trying to predict meteor crash in 1,000 days? So every time I sample, and most of the time, of course, there is no meteor crash, but just once there is a meteor crash. And when I now, train the algorithm, it will give me great results. It will give me a great accuracy, but it's not doing anything, right? Because I'm unable to predict this one-time meteor, but my accuracy will be awesome, because the total amount of true negatives is very high compared to the total amount of cases. So this is an example of where accuracy as a metric is not really useful. Now, that's classification, another form of supervised learning. And let's look at an example of unsupervised learning. Let's look at an example of clustering. And the example of unsupervised learning is that we do not have the outcome variable. We don't know. So in this case, in this example here, for clustering, we're using flowers, and we have the length of the flower and we have the number of petals of the flower. Remember the example I gave you before we went to regression? Right? Then we labeled the flowers, but now we don't have this labeling, so we're going to try to find clusters. How are we going to do this? Well, let's first put it on a two-dimensional plot. On a horizontal axis and on a vertical axis, I'm going to place the length of the flower and the number of petals. Next up, I'm going to decide how many groups do I want to find. And I determine I want to find 3 groups, and that is called K. So I'm going to find 3 groups, and I'm going to place 3 data points randomly on this grid. And I'm going to call those centroids. And then I'm going to determine which are the nearest flowers of these centroids based on the mean distance. Let's make it a little bit more colorful, and here it is. So I found the nearest flowers. Next up, as this cluster algorithm is doing, is I'm going to place the centroids in the middle of the flowers it found. So here it is. Now it is nicely in the middle. And then again, I'm going to find the nearest flowers based on the mean distance. So let's see what happens now. Aha, okay. New thing. Again, placing the centroids in the center, and again, and again, and again. And this iterative process repeats itself until, it stabilizes. And let's show that. And here we go. Now we see we found 3 groups, and we adjusted the centroids based on the mean distance. Now, this clustering algorithm is called K-means clustering. And that is a simple example of clustering. And with that, let's go to our second lesson of this module. And in this lesson, we'll be talking about Azure Machine Learning. And, what is Azure Machine Learning? And we'll look at the automated machine learning, and we'll look at the designer. But first start at what is Azure Machine Learning? Well, simply said, it is a cloud-based platform for machine learning. And, to use Azure Machine Learning, you'll need an Azure subscription. Otherwise, you won't be able to use anything. And in that subscription, you can create an Azure Machine Learning workspace. And a workspace is a logical container for resources you need to manage for your machine learning projects. And one of the most important resources here is compute. And remember when I talked about training times and that it would take forever on your laptop? Well, now you're in the cloud, so you can take this massive amount of compute and really, really, really reduce your computation times. But you need compute. The second one is also, pretty obvious. Well, you'll be needing data, right? You need to manage your data, and without data, you can't train your models. And another thing, which I think is absolutely fantastic, is experiments. So in the old days, the data scientist would be behind his laptop and just trying out things, trying different algorithms, trying different features. Days go by, and at some point, the data scientist realizes, 2 days ago, I had the best result. Oh man, but what did I use again? Did I use this feature? Or did I use that algorithm? Where's my documentation? Oh wait, I didn't write any documentation. Yeah. So, now, Azure Machine Learning tracks your experiments for you. So you can just easily go back in time and see when you got the best results or when you got completely different results. So that's a really great feature for Azure Machine Learning. Also, of course, when you have models, it stores the models. You can register and manage them completely in your workspace. And when you're ready to use your models in applications, you can publish them as services. And that can then be accessed over HTTP connections. So that is really a very short overview of Azure Machine Learning. Now, to give you another short overview, let's go to automated machine learning. Because automated machine learning is great. It takes a lot of hard work away from the data scientist. Normally you have to you tweak your features, you tweak your data, everything is ready, and then you're going to run the models. And then you're going to run a model. And then you're going to run the same model, but doing a little parameter a little bit different. And again, you have to wait. You're going to run the model again, doing a little bit differently, and again, you have to wait. So it's a very boring process, I would almost say. And why not automate this, right? Why not let Azure Machine Learning go through all these algorithms and all these different settings by itself? And then finally, it gives you the best model back. Now, that is automated machine learning. There's nothing to it. And I'll demo this later in the Azure Machine Learning Designer. But before that, let me just quickly tell you about what the designer is. Because the designer it's a visual tool for creating machine learning pipelines. And a pipeline is basically a multi-step workflow to prepare data, train models, and perform model management tasks, as you can see here on the right side of the screen. On the left side here, you can see that these three main steps are important. You start with a pipeline that ingests data, pre-processes it, and then trains and evaluates the model. And then when you're happy with the results, you create an inference pipeline, which is based on your training pipeline. It will be a little bit different because this inference pipeline only needs to score, so it no longer needs, for instance, to split the data. And if you're happy with that, and the inference pipeline is ready, you can deploy it as a service that then client applications can use. On the right side here, you can see an example of a training pipeline. And note the following. First of all, we need data. So again, we have our diabetes data. Remember, in the classification example, we also had diabetes data, and now we have it again. And I have the data, but before I can use the data, I need to process it a bit. And in this case, I'm going to normalize the data. So what I want it to be, I want all the values to be a little bit on the same level. I'm going to normalize them and making all between 0 and 1. It's a very common pre-processing step for numeric features. After that, I split my data, and one part goes to the train model and the other part goes to the score model. The train model will train my data, and the algorithm that I'm going to use is a two-class logistic regression, which is a binary regression. It's going to predict either a 0 or a 1. After training has been done, my model gets scored, and then in the final module, I can evaluate my results. And I'll show you that later. So with that, let's go to the lab, and I'll show you around. You can do this yourself. Go to aka.ms/nocodeautoml and just follow the instructions there. For now, I'll just create an Azure Machine Learning workspace, show you around in the compute targets. We're going to explore the data a little bit, train a machine learning model, look at automated machine learning, and then we're going to deploy the model as a service and even test it. Okay, so let's go. I've already put the link in a browser, so let me just switch to the browser here. And you can see here at the top of the screen, I already have entered here aka.ms/nocodeML. So let's run this, press enter, and it will open the learning path associated with it. Use automated machine learning in Azure Machine Learning. You can see that the third here is create an Azure Machine Learning workspace, and it will explain to you how to create a workspace, and the steps after it will ask you to go to the machine learning workspace itself and then open up the designer. But let's see first how to create a workspace. I need to go to the portal. I've already opened that in a separate tab here, and I can create a new machine learning workspace by actually multiple ways, but I could click here, I could type it at the top of the screen, I could click here and then add a new one. There are many options here. I can even, if at the flyout panel that gets here, I can even press create. And it will open up a new window where I can create my machine learning workspace. I have to choose a subscription, I have to choose a resource group, because remember folks, you cannot create resources without a resource group. It needs a name, which is unique within the resource group. I'm going to give it AI Fundamentals. Let's see if that's unique. It gives me a green tick, so that's unique. I'm going to provide it the region, and since I am from the Netherlands, I'm going to say North Europe, and the workspace edition is Enterprise. Again, if you want to use Azure Machine Learning Studio, you will need to choose the Enterprise Workspace Edition. With that, I click Create and Review and Create, and it shows me some of the basics. I check it, everything is correct, and I can press the Create button. I'm not going to do this now because I've already created some workspaces. So let me just go back here, click the Home button, and if I click here on Machine Learning, it will show me my current Machine Learning workspaces. I see that I have 2 workspaces in different subscriptions right here, and let me just click the top one, the AI 900 AML. It brings me to this overview where I can see some of the settings where I chose the Enterprise Workspace Edition. The resource group is AI 900, the location is North Europe, etc. If I scroll down, I see, well, in a big font, Azure Machine Learning Studio, and I can open it up by clicking the Launch Now button. This actually will open up a new tab and starts loading Azure Machine Learning Studio. And here I can use the designer and